So here we have gram mole to atom conversions.
A gram to mole conversion is a simple two-step problem. You refer to the periodic table to get the mass of the element or compound that you're working with. You start with your given value, then put the mass in the box diagonal from it, line your units up, and it's always over 1 mole. Then calculate it and get your answer. So if you have 4.62 grams of H2O, how many moles are there? So you would start with your given value, which is the 4.62 grams of H2O. And then line up your units and look at the periodic table, and you find that H2O, the mass of H2O is 33.006 then grams of H2O for every 1 mole. Then in your calculator, you would divide the 4.62 by the 33.006 and get 0.140 gram or moles of H2O.
Now we have moles to atoms, which is another two-step problem. So you start with your given value of moles, and then whatever compound you have, you put that diagonally to the bottom with just 1 mole, and on top you're going to put Avogadro's number, which is 6.02 e to the 23rd. And so here's for the example. You're going to start with 3.0 moles of NaCl, which is the given value. And then diagonally to that in the bottom box, you're going to put 1 mole of NaCl. Right on top, you're going to put 6.02 e to the 23rd, which is Avogadro's number. And when you multiply all that out, you are going to get 1.8 e to the 24th atoms of NaCl. Sorry, the pen's moving a little slow.
Okay, a gram to atom conversion is a little bit of a longer process. It's a 3-step problem, and you're using both the periodic table and Avogadro's number. You start with a gram to mole conversion using the periodic table, and then a mole to atom conversion using Avogadro's number. And you multiply the top and then the bottom, divide them both by each other, and you end up in atoms. So, the example, how many atoms are in 8.73 grams of MgO2? Start with the 8.73 grams. Of MgO2. Across from that, you would put the mass, which is 56.303 grams of MgO2. And that's for every 1 mole of MgO2. Match your units up, so for every 1 mole MgO2. You then use Avogadro's number, so 6.02 e to the 23rd atoms of MgO2. Then you get to cross out your units, so you have grams of MgO2 and grams of MgO2, then moles of MgO2 and moles of MgO2, and you're left with atoms, which is what you're looking for. So calculate that, and you get 9.33 e to the 22nd atoms of MgO2.
And still moving slow.